Hi there, welcome to another video of Code Rash with Gaurav. In this video, we are going to look at the most popular ways of copying objects in JavaScript. We'll also look at what is deep clone, what is shallow cloning, and in what all ways you can do deep cloning in JavaScript. We'll look at some popular ways like Lodash. Many people use Lodash for deep cloning their objects, but we'll see how that would have been implemented because mostly in interviews, people won't be interested in asking you which library you would use, but they would ask you to implement deep clone from scratch. So we'll see how can we do that. And also there is I want to cover a very important topic in this video that many people trust on JSON stringify and parse for deep cloning objects. We'll look at what are the problems in this approach and why you should not be relying on it. So stay tuned and let's get started. Now, before we jump into what is cloning and how do we do that in JavaScript, it is important to remember what is the reference and what is a value in JavaScript or any programming language. Now, back in my days, the first programming language we used to learn was C. So, what is value? What is reference? What is passed by value? What is passed by reference? Or all those concepts were pretty clear. Like it were made pretty clear. In JavaScript, you should understand if you are in case you are starting your career with JavaScript and JavaScript is the first language you are learning. So it is good to know what is a reference and most of the non-primitive data types you will create in JavaScript, they are going to be references. So I'll give you an example. Yeah. So let me create a string and let's call it ABC. Now in this case, str is a variable and it is pointing to a value which is ABC. It is not pointing to a reference. Let us understand why do I say that. Let us create another variable. Let's say str2 and that is, let's say, pointing to str only. What we are doing here is we are copying the value of str into str2. Now what does gets copied, that is the primary difference here. So in this case, because str was pointing to a value not a reference, str2 is also now pointing to a value. So if we say what is there in str2, we should see ABC. Pretty straightforward. Now let us say str2 equals to, we're going to change this string and we're going to say xyz. Now in this case, because str the initial variable and str2 that we just created, they are now pointing to their own values. They are not going, the change in any of these variables is not going to impact the other variable. So in this case, when I modified str2, str should remain unmodified. So let us verify that fact. In str we still have ABC. Now this is not the case when you deal with objects or any kind of a reference variable. Now let us see that. Let me create an object and let me have two values in that, a and b, which is 1 and 2. Now if we create an object out of this, let's say obj2, and we are assigning obj into obj2. Now at this point it is good to remember that how this would have been implemented. A memory location would have been created where the contents of these objects are stored, and that memory location is then being pointed to by obj. Now obj is not directly pointing to an elementary value, it is pointing to a reference, and when I assign that reference to obj2, now obj2 is also pointing to that reference only. So this is basically assigning a reference. When we talk about passing such objects or variables in a function, there we talk about passing by reference or passing by value. Here it is assignment of a reference. So when I say obj2 here, I should expect the same object structure a and b. Now it is good to see that when I say object2 dot a equals to 2, now modifying the a key in object2 and I am assigning it to 2. Now object2 should have a and b both as 2. Now let us see what is there in initial object now. You see that it is also changed. Object we initialized with a and b, which was 1 and 2. Now it is 2 and 2. But we didn't modify obj. We modified obj2, obj2 dot a. Now this is only possible because obj and obj2, they are pointers. They are not actually holding a value. They are pointers to a same memory location, and by doing this we are modifying the contents of that memory location, and because both of the variables are pointing to that memory location only, change in one variable impacts the other variable as well. To understand this graphically, so we created obj, then we created obj2. They both started pointing to a same memory location, and when you clone objects like this, you will get a shallow clone, because both like either in your entire hierarchy tree of an object, somewhere they are pointing to the same memory location. So this cloning or this kind of a copying object would be called as shallow clone. But if you really want a deep clone, the memory content which is allocated for that object, there should be a fresh copy and a deep copy created for that entire memory and that entire content of that object, and obj2 should then the clone object should start pointing to that memory location, so that any change in any of these variables or objects should not impact the other one. So this is basically deep clone, and we'll learn how can we implement deep clone in JavaScript from scratch. To begin with, we will first see what are the most popular ways of copying objects or cloning objects in JavaScript. And we'll see, do they really do a deep clone? The first popular method of copying objects in JavaScript is JSON.stringify and parse. So pretty straightforward. You first convert an object into a JSON string by using JSON.stringify, and that string you convert it back to an object using JSON.parse. Now this object which you just parsed, this should be a deep clone of the object which you started with. We'll see what are the shortcomings of JSON.stringify and why you should not be depending on this. Another popular method is object destructuring. We'll look at the aspect that does it really do a deep clone. Another way is object.assign. So we will also try to copy an object using object.assign and see, is it really a deep copy or is it just a shallow copy. So to begin with, I have this basic setup ready where I'm just logging a console log, and if I run using Node, I just pass this file to Node.js. I should be able to see a console here. So we are good to start. So let us first try out the most popular method, which is JSON.stringify. Now what I'm going to do is I'll just remove this console and I'll just console log. We'll first do a JSON.stringify of the object that we want to clone, and we will do a parse of this string, JSON.parse of the string that we just got from the JSON.stringify. Now let us run this. Okay, so you should see an interesting result here, that we had a function in our object which was with the key E, and there was an undefined with the key F. In the cloned object, we are not having those keys. Those keys are just gone. Now there is a reason for this, and this is the main reason you should not be depending on JSON.stringify for deep cloning or even shallow cloning your objects, because JSON is a format which is mainly used for data interchange over the network, and for which in that JSON structure, having functions, having values like undefined, these are not natively supported. So based on JSON standard format, these keys, these values like function and undefined, these will be completely omitted. Other types like date, let's say that you had a promise object or a date object, a regex object in your object that you want to clone, all those would have been stripped off when you are trying to do a JSON parse or JSON stringify. So this is a very unreliable method of cloning objects. But let us also see, say that we didn't have this requirement of having functions or non-standard values in our object. Let us see, are we really getting a deep clone? So let us first see, let us copy this guy in a object. Let's say clone, and we have this cloned object. So we will log clone here, and let us also log what was the original object. Let us see obj, and to have better logging, let us give it a string. To identify this in the log, we'll see cloned, and this, let's call it original. Okay, so let us run this. Okay, in the cloned object you see that E key is not there, F key is not there, and we are able to log it properly. Now we want to verify, is this really a deep clone? Now if you look at object, the object has a key B which is actually pointing to an array, and in JavaScript, arrays, objects, these are the variables which usually point to a reference. They are always always referred to as a reference. Now 1 2 3 actually will be stored in a memory location, and there is a pointer B which is pointing to that memory location. Now in this case, if we do a cloned object, the B key in clone object and the B key in the original object, our purpose of doing a deep clone is only met when these two are now pointing to different memory locations, which actually is a deep clone. Now let us try to verify that. What we will do is, let us say clone dot B dot push, let us push another entry in that, let us say 4, and let us log it again. Let's see how are our original and the clone objects changing with this. Now you see in the cloned object I pushed 4. Now in clone I have in the B key 4 as an entry added in the array, but my original objects remains untouched. So this is a pure deep clone, but it is not reliable because it omitted some of the entries which I was interested in deep cloning. So we saw that json.stringify actually does a deep clone, but it is not reliable because it will only copy and retain those keys in the object which are standard values supported by the JSON format. Okay, so the next stop for us is the object destructuring. Let us see if how do we actually copy object using object destructuring, and let us see if our purpose of having a deep clone is met with object destructuring. So we're going to change this guy to just object destructured of the original object, and let us remove these consoles to avoid confusion and have clear logging. We are going to push in the clone object, we are going to push 4, and let us see what do we get. Let me clear the console and run it again. So in the cloned object, we are getting all the keys here. So one good thing about this kind of a cloning is at least it retains all the things that I had in my previous object. So I get everything in the cloned object, and in the original object is also changed. So I did a object destructured clone or in this clone object, and in the cloned object I am saying in the B key, which is an array, I am trying to push an entry which is 4. Now when I am logging both the objects, we are seeing here the B key, which is an array. Now both the entries are having another entry in the array at both the places. That means this would have been possible only when object.b and the clone.b both are pointing to the same memory location which was initially assigned to obj. Now this is basically a shallow copy, which is not what we wanted. So we learned that object destructuring does a shallow copy and it retains everything that we had in the previous object. Let us also see another popular method, which is object.assign. We will see what kind of a copy does it do. Is it deep or is it a shallow copy? So for that, let us use object.assign here, and the format of that is you should be giving a target object here and the source object here. So our source is going to be object, and this object we want to copy in this, and this guy returns an object which we are assigning it to clone object, a clone variable. Now let us clear our console and run this. Okay, so in this way also we are observing that all the keys of different types of values in our object, they are retained. So I'm getting everything in the cloned object as well, which was there in original, but when I do something with the cloned object, it is also reflecting in the original object. So that means this is a shallow copy. So using object.assign also we are getting a shallow copy where object.b and clone.b, they are pointing to the same memory location which was initially assigned to obj. Now this is again not what we needed. So we learned that object.assign gives us a shallow copy, but a good thing about object.assign is unlike json.stringify, it gives us all the keys which were present in the original object. So far with any of these methods, we did not see a deep clone happening which also retains everything in the object. JSON.stringify did a deep clone, but only those standard value types which are supported by JSON. Now we want everything to be deep copied. How do we do that? So what we are going to do is we are going to write a custom method for doing so, and which is going to be recursive in fashion. Let us do that. So we're going to have a function defined. Let's call it deep clone. This guy is going to take an object as an input and return us the deep clone of it. So let us create an object which we want to return from here, deep cloned object, and let us say that it is a blank object for now. And what we are going to do is, at a very basic or a minimum thing to be done here in this function, we're going to say for const key in this object. Let us go through everything in this object and let us say that in the deep cloned object I want to copy that key. But here is a challenge that when you are parsing every key in this object, the type of a particular key, the value type of a particular key is not deterministic. Like it can be an array, it can be an object. Now this nesting also is not determined at first. So B is an array of elementary values right now. This could have been an array of objects, and that object could have had an array further. So this can go up to any level which you cannot predict. So that is why we are trying to solve this with recursion. So in the deep cloned object, the key the value which we are going to assign to this, let us call this function recursively, because we don't know till what leaf level and up to what levels it is going to go. So we're going to just say obj of this particular key. Now when we are going to come here in this function back recursively, let us do some checks on the type of the values that we are getting. Let us handle the falsy values first. So let us say if type of, or let's say if not obj, that means it was a falsy value, let us just return obj from here. So this should take care of the undefined case, which is a falsy value in this case. And if the type of the input that we are getting is not an object, that means it is an elementary value, we don't need to perform any special operation there. We can just return this object. And we need to also take care that this could be an array. So we need to do something special for cloning arrays. What we will do is, if array dot is array, we're going to first find out whatever we are getting as an input in this function, is this an array? And if that is true, we are going to return a cloned array from here. So let us initialize that and say that our cloned array is empty to begin with, and then let us say obj dot for each. Let us go through each and every entry in this array, and let us do one thing. Again, like we discussed in this problem, that B is right now pointing to an elementary array. There is a chance that this array could be an array of objects. So there is no limit to the nesting level you can go, and we are not going to imagine that or make an assumption here. So what we are going to do is, we are going to say cloned array dot push. Let us call recursively again a deep clone on what we are getting. So if it is elementary value, I'll just get that back, and if it is not an elementary value, it is an object, or there is some nesting level inside that, let us
go further into deep cloning that. So I'm going to say deep clone of E. And what we are going to say here is, after all this done, let us just return the cloned array from here. Let us just return the cloned array. Yeah. So we are taking care of each and every key that is coming in this object, and then we are recursively calling our deep clone method. Now when you are passing something to the deep clone, if it is if there is no special logic to be applied over there, if they are elementary values, we are just returning those elementary values because they are not pointing to a reference, they are elementary values. We'll encounter reference cases where we want to go further into deep cloning when we encounter some arrays or objects where we are calling our deep clone utility recursively to go further deep down into deep cloning that entity again. Now once we are done with all this, let us return our original object which we initialize with blank, in which we are putting all these keys. Let us return deep cloned object from here. Now to test this, instead of object or assign, let us call this method deep clone, and we are just going to pass object to this. Now let us try this out. Okay, so we are getting in the cloned object every key that was there in original, which is the good thing, which we wanted. And also if I am playing around with the clone object, my original object is not touched. So I push another entry in the clone object's B key. The original object remains intact the way it was before. Now this utility helped us in getting a deep clone recursively, and also it retained everything which was there in the original object, which couldn't have been done with any of these. So JSON.stringify had a pitfall that it was not copying everything, though it gave us a deep copy. Destructuring an object.assign didn't give us a deep copy. Now such a utility lets you do a deep clone, and also it retains everything. So this solution can be further improved. Like this currently will not work for special kind of objects like dates, promises, or regular expressions. Like let's say our object had a regular expression. So these kind of things will have to be handled separately, and we are handling array as a case, we can handle such cases, and we can do some kind of a special cloning for such objects, say map or sets. So for such object types we can go further, handle those cases, and this gives you a basic idea that how can you really deep clone an object into another object in JavaScript.
So in today's lesson, we learned what is deep clone and how do we implement that from scratch in JavaScript. So if you like this video, please do leave a like on this video, share this video with your friends, and subscribe to this channel. Tell me in the comments what all topics should I cover next, and I'll see you in the next one. Thank you.